Hi everybody. All right, so today we're going to be looking at circular linked lists. All right, we've already looked at singular linked lists, and those were used to implement a stack data structure. We then looked at a doubly linked list and used that to implement a queue. And we just also want to talk about one more thing, and that's going to be a circular linked list. Now, this is a circular linked list is just a single linked list or a double linked list that has the last element. Instead of pointing to null, it points it back to the start element, the first element, whatever it is, in the linked list. All right. So yeah, I just created a file here. We're going to rename that. I'm going to rename that cll.java, and I'll have that all caps. All right, and then here I'm going to make public class CLL. All right, now before we actually write this, let's just talk about what we're doing here. Now, the circular linked list has a few advantages that I want to note. Any node in a circular linked list could be considered the starting point. We can go from any point and reach any other point in the list because it's a circle. So we can just keep going until we find what we want. This is useful for implementing a queue since we only need to know one point, the back point, in order to find the front or back of the queue. It makes it very easy because if you know where the last element in the singular linked list is, the element that last element points to is the first element. So that knowing that one position will tell you two things actually. And yeah, it's useful to implement a cycle of information and processes. For example, when multiple applications are running on a computer, they don't actually execute at the same time concurrently, but they execute actually so quickly, one after the other in a cycle, that it looks like things are happening at the same time. And, you know, we can model that using a singular linked list. But anyway, enough of me talking. We are going to write this class. Now, before we do, I just want to note a few of the things that we are going to put into this. We will implement the following. All right. First is the add front method that will accept some element e and puts element e at the front of the list. Pretty self-explanatory. So that'll just put something at the front of the list. I'll just copy and paste that, make my life easier. The second one we're going to do is add back. And those of you that are excellent at thinking through the context of a situation, this will put element E at the back of a list. And then the last one we're going to put in is a method we're going to call traverse. That doesn't need a parameter. And we just want this to look through and print every element in the list. All right. We've been doing it manually by just popping elements off of our stack or by just dequeuing stuff off of our queue. But we're just going to write a traverse method so that our circular linked list doesn't have to change for us to see what's inside. All right. So in order to get this circular linked list off the ground, as we do with all of our linked lists, we need to have a node class. All right. Now, since this is a single linked list, this node can be like the node classes that we have developed before. Member variables for node. All right, where it just needs to have an int value. Now, it doesn't always have to be an integer value. It could be any type of value you want to store in the list. I'm just choosing integer for the sake of example. And a reference to the next node. All right. We also want to make a constructor, and again, since we are the only people using this, we're just gonna write a parameterized constructor for this that sets the value to v and the next to null. All right. So we have our node. We have our node class that we can use to implement this structure. So let's get going with that. So first, let's get the member variables for this circular linked list. What do we need to know? All we need to know really is one thing: where the last element in this linked list is. Now, just for the sake of making, you know what, we don't need to know the size of this. We could just say private node last. You know what? Let's add a size variable just for funsies. All right, and now we can make our constructor. Let's make the default constructor public CLL. Last will be set to null because there's no element on it, and we can have size be 0. Alrighty. And we'll just do the add front for today. Then we'll do add back and traverse tomorrow. You know, maybe we'll have time, but we're already burning daylight here. The video's getting a little long. All right. So member methods. First one we're gonna put in public void add front. It's void because it doesn't return a value. And this will accept an integer parameter v. That's the element I'm trying to push into my linked list. All right. So now what we'll do is we'll create a new node. Node, new node is equal to new node v. Oh, how fun. All right. Now we need to check if our linked list is empty. If it is, so if our last is null, that means, well, last isn't pointing to any element. It's pointing to nothing because we've got nothing in our linked list. So if that's null, then we can just say last is equal to that new node that we created, and new node dot next is equal to last. All right, what does that mean? All right. If I can just pull it up here. Oh, all right, so if we say that, then let's say this is the new node that we're creating. Let's say we gave it a value of 6. All right, and let's say our list over here has last, and it's currently pointing to nothing, to null. So far with this first condition in the method, what we did is we said, all right, last no longer points to null. The last element points right over here to this new node, and then this new node will point to the last element. Well, what is the last element? It's this one. So it just points to itself. And that's the start of the circle. All right. Let's continue this. So what if the linked list is not empty? Well, if it's not, then new node dot next is equal to last dot next, and last dot next is equal to new node. All right, let's take a view of that. So here, let's just clean this up a bit. So far, our linked list looks like this, right? We have one node that references itself, and we keep track of this by knowing that last is right here. All right, so now let's say we wanted to add another node onto this. So what we do is we create another node. Let's say we wanted this one to have a value of 4. So we put it here. All right. Then we say new node.next is equal to last.next. All right. So we go to last and we figure out what's the next thing. Itself. So the next element for 4 is this one. Then last.next, which is again this over here, will point to new node. So now this no longer points to itself. It instead points to new node. And we can clean this up a little bit. All right. And I will. So here, let's just get rid of everything. So an equivalent diagram here. We have 6. We have 4. We know that the last element on our list is this one. 6 tells us 6 is pointing here, and 4 is pointing there. And that's how our list goes. So this will be the last element, then this loops back around to the front. This is the first element now in our circular link list, which is great because we have the add front method over here that we're using, so we wanted to add it to the front. And then this one will point to whatever comes after, which again just completes the circle. All right, what's one more thing we need to do here? Since we have that size variable, we just need to make sure that we're incrementing our size. So we would just say size plus plus. And now that I look at the time, we're already 12 minutes into this video. So why don't you guys stop there and we'll continue tomorrow. All right, guys, have a great day. Don't forget to do the attendance form, complete the attendance form, and I'll see you in the next one. Bye.